And the word that I'm putting here is part of my question into the system, and the word over here is the structured data on the back end. Everybody can see, does this string match this string? Do these texts match? Right, that's obvious. But what happens when I'm representing the same meaning between those two words, but they're different, right? I don't have your language in my structured database. Are you still able to find the content that you're looking for?
You're talking about something very simple like cat versus kitten.
Exactly, right. If I only have cat in my database and you want to do a search and you use the term kitten, and I look for kitten in my database or my index and I don't find it, well, then you don't get the result that you're looking for. But they mean the same thing. Well, to some degree, right? There's a relevance score that's associated with that. And this is where when we move from the lexical-based search to a semantic-based search, or even a hybrid of the two, you start inferring the relevance of what the meaning is behind the question and how it relates to the relevance or the meaning behind everything that's in your sphere of documentation, which can be structured and also unstructured, which is a really exciting thing because historically businesses only capture about 20% of their information in structured repositories. That means 80% of the things that the customers really want to know about aren't even available to them. And then for the 20% that they're using right now, they have to pick the right keywords in order to find that information. How limiting is that? So the AI in terms of the AI, the capabilities that we're talking about, it's a minor shift. We're not even talking about grand concepts. Really, whenever I say a semantic search, all I'm saying is I'm going to represent those words in a way that generates a mathematical meaning, and then I can just do a quick search much faster, in fact, than I can on text. I can do a enormous size library search very, very quickly and get the results. So when we take a look at the semantic based search or keyword plus semantic, the performance actually ends up being as good or maybe even better at times. In one recent client implementation, we saw improvements of 30% or 30%.
I think it was
300%.
300%.
300%. Yes.
Amazing. We talked a little bit about what your kind of a little bit cart before the horse just a second ago, and I want to get back a little bit, a layer deeper, and talk about the innovations that exist in the ingestion of structured and unstructured data. How do you get the AI solution you're trying to implement to know where things are or to know what to look for?
Well, let's keep it really simple. If I've got a text document, then I can go and take those words that are in the text document, and that may not be sitting in a database.
Right.
That may just be a text document.
Sure.
But
PDF.
For me to parse that text document, for me to go through that text box, there's not a lot there.
Okay.
Now, that's unlikely that you're just going to have a bunch of business information sitting in text documents, right? You're going to have PDFs, you're going to have presentations, you're going to have spreadsheets, you're going to have audio files, maybe even recordings with folks. You're going to have videos, and all of that is going to contain content that you may want to mine.
Just regular
Images. So what do you want out of what's in that content is one of the things that needs to be discussed. If your images contain text, then you're going to be doing what's called optical character recognition, where you're trying to infer the text
Sure.
content from the images. Or you're going to be doing speech to text translation so that you're going to go and get the text again from it. Or you're going to do something like object identification, where you're trying to basically label content that's associated with what is in those artifacts.